Hello, good evening, all of you, dear students. Actually, this is 10 o'clock at night, but I will say good evening instead of good night to all of you. This is the simplest and easiest way of teaching learning process. In our most favorite YouTube channel, Physics Make It Simple by Dr. Rajendra, now serving as a principal in लोकनेते डॉक्टर बाळासाहेब विखे पाटील पद्मभूषण अवॉर्डी प्रवरा रूरल एज्युकेशन सोसायटीज महात्मा फुले विद्यालय अँड ज्युनियर कॉलेज दाड बुद्रुक तालुका राहता डिस्ट्रिक्ट अहमदनगर. As long as 12th science syllabus is concerned, this is a chapter oscillation, and oscillation is concerned, this is a lecture number 9, dear students. And in this lecture we have to discuss about composition of two SHMs having same period. Period should be same, but amplitudes and initial phase angles are different. See here, these are the two equations of SHM that I have written here. x1 is equal to a1 sin omega t plus phi 1 and x2 is equal to a2 sin omega t plus phi 2. Here a1 and a2 are the different amplitudes, as well as phi 1 and phi 2 are the different initial phase angles. Listen carefully, amplitudes of both the SHMs, initial phase angles of both SHMs are different. Only the period is same. Period is hidden in omega. Here omega is equal to 2 pi upon capital T. This is also omega is equal to 2 pi upon capital T. So period is remaining same, and so that I haven't written omega 1t, omega 2t. Omega remain constant because period is constant, and so that we have taken two equations of SHMs. x1 is equal to capital A1 sin omega t plus phi 1, and second one x2 is equal to capital A2 sin omega t plus phi 2. Periods are same, amplitudes and initial phase angles are different. Such a two SHMs are traveling along the same path. When these two SHMs combine together, then we get resultant SHM. This resultant SHM mainly depends upon the principle of superposition of waves. What is principle of superposition of waves? When two SHMs are combined, interfere, superimpose with each other, then resultant displacement at any instant is vector sum of the displacements of two waves at that instant. Vector sum, because two SHMs are, the displacements of two SHMs are, if along the same direction, then there will be addition. If the displacements of two SHMs are opposite, then there will be subtraction. And so that we have written the word vector sum. So resultant displacement at any instant is vector sum of the displacements of two waves at that instant, and this is called as principle of superposition of two waves. Best way, in short, we can say that composition of two SHMs depends upon, based upon principle of superposition of two waves. And so that I have taken two equations. x1 is equal to capital A1 sin of into bracket omega t plus phi 1, and x2 is equal to capital A2 sin into bracket omega t plus phi 2. Remember well again, period remains same, but amplitudes and initial phase angles are different. This A1 and A2 are the amplitudes, phi 1 and phi 2 are the initial phase angles. They are different, but period is same, and so that instead of omega 1 and omega 2, remember well, it should be omega here, it should be omega here. Then resultant displacement is given by vector summation of two displacements. So capital X is equal to capital X1 plus capital X2. That I have written on the board already. So capital X is equal to X1 plus X2. Capital X is equal to, what is X1? A1 sine into bracket omega t plus phi 1 plus A2 sine into bracket omega t plus phi 2. I have put the value of X1 and X2. Only I have put the value of X1 and X2. Then we remember the formula sine of A plus B. See here, sine of A plus B. What is sine of A plus B? Sine A cos B plus cos A sine B. See here, capital A1 is common, sine A cos B, sine omega t cos phi 1 plus cos A sine B, cos of omega t sine phi 1. This is the simplification of sine of omega t plus phi 1. Then here, capital A2 is common. What is sine of omega t plus phi 2? A plus B, sine omega t sine A cos B plus cos A sine B, like this. So in this way, this is the, by making use of a formula, sine of A plus B, this step arises. Then take a common, sine omega t are common. See here, sine omega t into bracket, what will remain? A1 cos phi 1 plus A2 cos phi 2 plus cos omega t is common here. So take a common, cos omega t into bracket, what will remain? A1 sine phi 1, see here, then A2 sine phi 2, see here. Then for our simplicity, let us imagine. What is imagination? The imagination is put r cos delta is equal to A1 cos phi 1 plus A2 cos phi 2. This term r cos delta. Then r sin delta is equal to A1 sin phi 1 plus A2 sin phi 2. Then equation will become what? Capital X is equal to sin omega as it is, A1 cos phi 1 plus A2 cos phi 2. Instead of this, we can write what? R cos delta plus cos omega t as it is, A1 sin phi 1 plus A2 sin phi 2. Instead of, we put R sin delta. Then again here, R is common, capital R is common, into bracket will remain sin omega t cos delta plus cos omega t sin delta. And this is the formula of sin of omega t plus delta, sin of A plus B. So in short, we can write capital X is equal to capital R sin of omega t plus delta. The bracket will remain here. The bracket will remain. I will give a bracket like this. This is the equation of resultant displacement of resultant SHM. Very simple. We get resultant SHM, resultant displacement of resultant SHM, we get is capital X is equal to capital R sin of omega t plus delta, where capital X is called as resultant displacement, capital R is called as resultant amplitude of SHM, while delta is called as initial phase angle of resultant SHM. Then the next is to find resultant amplitude capital R of resultant SHM. How we can find resultant amplitude? So we know R cos delta is equal to A1 cos phi 1 plus A2 cos phi 2, and R sin delta is equal to A1 sin phi 1 plus A2 sin phi 2. Let us squaring and adding above equation. We can write what here? R square cos square delta plus R square sin square delta, this a1 cos phi 1 plus a2 cos phi 2 bracket square plus a1 sin phi 1 plus a2 sin phi 2 bracket square. That means squaring and adding that equation, we get this. Then here r square is common. Inside the bracket we get cos square delta plus sin square delta is equal to, here make a square, a1 square cos square phi 1 plus a2 square cos square phi 2, multiplication of 2 and double the multiplication, we get what? 2a1 a2 cos of phi 1 cos of phi 2 plus here square of this bracket, a1 square sin square phi 1, we get this, a2 square sin square phi 2, we get this, multiplication of 2 and multiplied by multiplication of these two terms, a1 a2 sin phi 1 sin phi 2 and multiplied by 2, we get 2a1 a2 sin of phi 1 sin of phi 2. Then we get what? R square is equal to cos square delta plus sin square delta is equal to 1. So simply r square will remain is equal to, a1 square is common from these two, we get what? Cos square phi 1 plus sin square phi 1 here plus a2 square is common from these two terms, we get cos square phi 2 plus sin square phi 2 plus 2a1 a2 is common in these two terms and inside the bracket we get cos phi 1 cos phi 2 plus sin phi 1 sin phi 2. Again we get what here? R square is equal to a1 square cos square phi 1 plus sin square phi 1 is equal to 1 plus a2 square cos square phi 2 plus sin square phi 2 is equal to 1, only a2 square. This 2a1 a2 is here and this is a formula of cos of a minus b. Cos of a minus b is cos a cos b plus sin a sin b. We get cos of phi 1 minus phi 2. Take a square root on both sides. We get capital R is equal to square root of a1 square plus a2 square plus 2a1 a2 cos of phi 1 minus phi 2. This is the resultant amplitude R of resultant SHM. This is the resultant amplitude of resultant SHM. Capital R is equal to square root of a1 square plus a2 square plus 2a1 a2 cos of phi 1 minus phi 2. Then in the next step we have to calculate initial phase delta of resultant SHM. Again take these two equations. R cos delta is equal to a1 cos phi 1 plus a2 cos phi 2. R sin delta is equal to a1 sin phi 1 plus a2 sin phi 2. Then let us divide equation 2 by 1. 2 by 1 we get what? R sin delta upon R cos delta is equal to a1 sin phi 1 plus a2 sin phi 2 upon a1 cos phi 1 plus a2 cos phi 2. Here capital R get cancelled. Sin delta upon cos delta is equal to tan delta is equal to, this term remain as it is. Then delta is equal to, when this tan is transferred to RHS, we get tan inverse, and so the delta is equal to tan inverse a1 sin phi 1 plus a2 sin phi 2 upon a1 cos phi 1 plus a2 cos phi 2. And this is the initial phase angle of resultant SHM. In this way, in the composition of two SHMs, we got three formulae. Number 1, resultant displacement, capital X is equal to capital R sin of into bracket omega t plus delta. Then the second formula we got is resultant amplitude of resultant SHM. Capital R is equal to square root of a1 square plus a2 square plus 2a1 a2 cos of phi 1 minus phi 2. And the third formula, initial phase angle delta of resultant SHM, we got is delta is equal to tan inverse into bracket a1 sin phi 1 plus a2 sin phi 2 upon a1 cos phi 1 plus a2 cos phi 2. In this way, we have to prepare three formulae: resultant displacement, resultant amplitude, and initial phase angle delta of resultant SHM. So, after learning these, we will have to take a screenshot, and by taking a screenshot, we have to learn 3 different cases, dear students. So, before learning 3 different cases, take a screenshot at first. Take a screenshot. Okay. Take a screenshot and then we'll proceed further. Then we'll proceed further. We have to take a 3 different cases. What are that 3 different cases? That we will see. 3 different cases. What is the 3 different cases? We will see 3 different cases. Let us clean the board at first. Then it will make me more convenient to take a 3 different cases now. Okay. We will see 3 different cases. 3 different cases. Number 1, if 2 SHMs are in the same phase. If 2 SHMs are in the same phase, then phi 1 minus phi 2 is equal to 0. There is no any phase difference. Then what is the resultant amplitude? So write down the formula of resultant amplitude. Capital R is equal to square root of A1 square plus A2 square plus 2A1 A2 cos of phi 1 minus phi 2. Cos of phi 1 minus phi 2, that we get what? Cos of 0 degree, and cos of 0 degree is equal to 1, and therefore we get what? Capital R is equal to A1 square plus A2 square plus 2A1 A2, and this is the square of A1 plus A2. So instead of this we can write like this: square root of A1 plus A2 bracket square, A1 square plus A2 square plus 2A1 A2, like this. And by taking a square root we get what? Capital R is equal to simply A1 plus A2 plus or minus. We get capital R is equal to simply A1 plus A2 if 2 SHMs are in the same phase. Then resultant amplitude we got is capital R is equal to either plus or minus A1 plus A2. Then suppose if A1 equal to A2 will happen equal to capital A, then what happens? If A1 equal to A2 is equal to A, then what happens? Then we get capital R is equal to plus or minus A plus A. So we get capital R is equal to plus or minus 2A. This condition arises if A1 is equal to A2 is equal to capital A. Take a screenshot. Okay. Then we'll proceed further. If phase difference between 2 SHMs, we will write like this: if case number 2, if phase difference between two SHMs phi 1 minus phi 2 is equal to 90 degree or pi by 2 radian. So what is capital R? Capital R is equal to square root of a1 square plus a2 square plus 2a1 a2 cos of phi 1 minus phi 2 square root. So what is phi 1 minus phi 2? Cos of 90 degree, and cos of 90 degree is equal to 0. If cos 90 is equal to 0, if we put this, then only capital R will get is a1 square plus a2 square. If a1 is equal to a2 is equal to a, then we get what? Capital R is equal to a square plus a square is equal to square root of 2a square. So capital R will get is root of 2 into a. So this is the formula. If a1 is equal to a2, then resultant amplitude is this. Take a screenshot. Take a screenshot. Okay. The next article is, next case is, not article. Next case is, if a phase difference between two SHMs is 180 degree, we can write here. If phase difference between two SHMs is 180 degree, or we can say that it is pi radian, then what happens? Write down capital R is equal to a1 square plus a2 square plus 2a1 a2 cos of phi 1 minus phi 2. Take phi 1 minus phi 2 is equal to 180. So cos of 180 degree, and cos of 180 degree is equal to what? Minus 1. Put here minus 1. So we get what? R is equal to square root of a1 square plus a2 square plus 2a1 a2 cos 180 is equal to minus 1. So we get is capital R is equal to a1 square plus a2 square minus 2a1 a2 minus 2a1 a2, and this is the square of what? Capital R is equal to square root of a1 minus a2 bracket square, and so that we get capital R is equal to plus or minus a1 minus a2 like this. Here again, if a1 is equal to a2 is equal to a, then resultant amplitude we got is 0. A minus a, we get 0. If both the amplitudes are same, then, and if the phase difference is 180 degree, then resultant amplitude of resultant SHM we got is 0. So these are the three different cases regarding composition of SHMs, and in this way this is a lengthy article and mathematical steps. The articles having mathematical steps we have finished here, and again we will meet in the next lecture. Till goodbye.